Good evening and welcome to this seventh, I guess, session on the same topic. I've taken a bit of time to write a bit what we are trying to do. Hopefully it will help people who are joining midstream to understand a bit what we are trying to do. So the context is a neural network inference framework, and there are activation functions. So these are functions that you must execute on each and every element in a tensor, regardless of any kind of geometry in the tensor. So basically you can look at the tensor as just a big slice of number, and we need to apply the same y equals f of x function on each and every element. And the fact that there is no geometry involved and that each computation is independent makes them a very good candidate for SIMD optimization. So the problem with that is there are like 6 or 7 easy ones and a bit more complicated ones. And we don't want to write assembly for all of these on all the architectures that Tract is supposed to support. So what we're doing is a virtual machine. We have been defining a microcode in which we can encode all of these activation functions, and we are implementing a microcode interpreter in assembly on each and every architecture that we want to support, given that for now it's just one architecture, which is ARM 8 SIMD coprocessor. So I've also tried to write a few, to kind of list what I think is a kind of roadmap to production for this feature. Basically, we've done this, that's what remains. So we're not done yet. And so I think we will just jump right in. And the first thing that we are going to look at, I think, is this one. Because I want to change... I had a lot of time to think about it because I just a couple of hours every week. So it gives me a lot of sleepless nights to redesign it. And I think the way we have been separating the constants from the main thing in the program is not right. So let me show you. Let me show you that. So this is, yes, download. So this is our program. It's made of operators and constants. So operators is just the big enumeration, which is here, and it defines every simple operation that we need to be able to do in our virtual machine. And so a program is made of a sequence of instruction operation called ops, and these constants, which are the constants involved in computing the activation function. For instance, a very simple one like relu, which is the max with 0, will have 0 as a constant and will be made of just this operation. If I look at its definition over there, we have relu, and it's just max const and the done operation that says that we are done, plus the constant 0. And then this 0 is not the value 0, but it points to the constant number 0 in this table. So this is what I want to change. Because that means when we are going through the operation and executing them, we are essentially looking at operation, And when we find an operation that contains a constant, then we must do a second memory lookup to find the actual constant value. And I think it's an unnecessary complication. Initially, I did that because I wanted the constant to be small. I wanted the operation to be small, but really it's not that important. So I think we are going to change that before doing much more work in implementing the operators. So what does it mean? It means that a program will just be a sequence of hops. So I'm going to simplify it like that. No, I'm keeping the structure. I'm keeping the structure because I suspect at some point I will want to give them a name, just for auditing and debugging purposes. So now what will happen is the operators will contain, instead of containing constant IDs, they will actually contain constant values. So it will raise interesting question of packing. Let's find out how it works. So here I will have to, so far the constant was universal, meaning that regardless of whatever was the operation type, whatever was the type of the number we were operating on, the operator was the same. But now we are going to include there one of the LA datum, which represent the different types that the different numeric types that Tract can operate on. And so this guy goes away, and this becomes T. And all of these also become T. And the question is, I have no idea how Rust will encode this structure. I'm going to explain that. And we will have to look at the doc. So what is the problem with this? The problem with this is I don't know when we have this. So we have said that the discriminant of our enumeration is U16, so it's 2 bytes. And to store register ID, we've picked 1 byte. So the question is, where will Rust put this T? In specifically this example, for instance, will it try to align the T? For instance, if the T is F32, will it try to align it with a 4 bytes boundary, or will it be wherever it falls, meaning after the third byte starting from the beginning of the enumeration? So that I don't know, and we need to figure it out, because when we will read them from assembly, we must know where every bit can be found. Okay, so how to find out this? Well, first we will have like many things that do not compile and that we need to fix before moving on. So let's see. So the first thing that changes is the run function for the program will no longer, we will no longer have constants. So let's get rid of the constants. slice. Okay. Same here. That's so the constants are gone, and instead we have operators parameterized by t. Then we have our actual implementation. So this is a function, the assembly function. So we no longer need the constants, and we no longer need to pass the constants either. So we can get rid of this and that. Here we go. Let's run a cargo watch and see what else we have to fix. Okay. So, where is that? Generic. So generic is the Rust implementation of the activation. So for now it's only okay, so we have some work to do because it's F32 and only F32. So we'll need to fix it. Okay, let's do this. Yeah, we will do a couple of things here. So before we jump in, let me have a look at what we have to do. Okay, that one is easy. So just okay. So for now, we'll say that we just have a F32 implementation. So I can get rid of the constants. Okay. And okay, so the constant now no longer comes from the constant table. It's just this guy constant. It makes it much easier actually. Okay. Same. So here we don't have the problem with the layout because Rust understands its own structure, but that's a luxury we don't have in assembly. We need to know for sure what Rust will do and see how we can match it. Okay, one more. And one more, 79. Yes, so constants are gone. And op is a op of F32. Okay, something not right. All right. We don't need these stars all over the place. One more. here. Okie doke. Fantastic. Activations test. That's in frame. So frame is where the code in frame works whether whatever is the architecture, or if it's Rust fallback implementation. So frame is always called. It's a generic part of linalg. So here we have a bit of a change because now max const. So we were going to use these. Here we no longer need the constants. And this is this is item number 2 on the list. I want to collapse all this test into one macro, I guess. If the answer is a macro, and I guess it is a macro that we need. More. Okay. Ensuite, then we have src frame activation. So I need to fix, of course, the definition of all of the macros. So constants are gone, and this is t of 0. So here I will need to make some constants. That one is easy because it's t0, and I think I also have 1. Yes, but the other one will be more complicated. Oh, plus. Okay, so in this case it's not 0 and 1, it's alpha and beta. So no problem here with finding out the constants. Here we have alpha, so alpha goes here, and this guy goes away. So here we have alpha here. Nope. So what are the constants? Constants are t0 and alpha. So t0 is 0, and this one is alpha. Then we have, so this 0 is a 1. It will be it will be incredibly less confusing. All right, so this one is a tricky one. So max const 0 is t0. Min const 1. And so these guys, I'm gonna name them to make it easier. So this one is 1 fix. This definition is a bit extreme, but 1 alpha. At least it works. It should be perfect, as in no extra rounding. 1 alpha. So this is 1 6, and this is 1 alpha, and the constant can go away. Okay. We still have, it looks like we still have a constant somewhere, which I've missed. src generic activations. Yep. So constants is gone. Okay. So I'm gonna run a cargo test. I'm gonna run it on an Intel machine. So it will test the, it will only test the Rust fallback if it compiles. SRC frame activation, because the current implementation has, we have a Rust generic implementation, which is the one we just fixed, and we have an ARM64, so an ARM 8 actually, implementation that we did not fix. But as it is in assembly, the compiler will not realize that it's broken. Okay, so here, now I'm gonna have to specify this, and the size of this, I guess, will be 8, but I'm not even sure about this. It might be 7, actually. Size of op, 12. That was unexpected. Okay, why 12? Why? Why does it make it 12? This is really surprising to me, because F32 is 4, so the biggest one is like this one, where we need the discriminant plus, yeah, we need discriminant, so discriminant is 2 bytes. We need a register ID, which is this guy, which is 1 byte, and we need a T, which is 4 bytes. So why the hell does it count 12? I'm starting to wonder if the representation is dependent on debug or release. So let's try with the release flag and see if we have the same weird result. Because I'm happy with 8. If we can force it somehow to be 4 and 4, because that would make it very easy to read and parse in assembly, because the first group of 4 bytes, the first 32-bit integer, is the definition, I mean the opcode, eventually the register ID, and then we have a 4 bytes, a line on 4 bytes, F32. If the float starts not to be on the boundary, then it would just be a bit more complicated. And here we have 12 bytes, so we need to load 164-bit number plus 132-bit number, so it's a bit of a mess. So I hope we can curse Rust into using a sensible definition for this enum. While it compiles, Rust enum representation repr C. So that's some so we need to figure out what how Rust represent this structure, and enum with field aren't a concept in C or C++, but a valid bridging of the type is defined. So here we go, and checking if we are done. We are done, and we still have a 12. Okay. Okay, we need to understand what's happening. So we have an enum with 3 values, and there are a new 8. So this one is easy, this one is easy too. Now consider, okay, that's the one we are interested in. Consider adding a wavy line style, which requires an extra thickness value. Line style U8, okay, and this is exactly what we have. So we have a representation for the enum discriminant plus this parameter for the operator for the variant, and we need to figure out how is this encoded by Rust. So we cannot safely pass this to and from C or C++. Now can we manipulate? No, I think this is the I mean, this is an RFC, so it states that's the part where it states the problem. We are not yet at the solution. In place construction, blah blah blah. Not sure that's super relevant. Wide level explanation. So an enum can currently be added by represent int, where int is one of Rust integer type, blah blah. For C-like enums, enum which have no variance with the state data, okay. This specifies that the enum should have the ABI of that integer type, size, alignment, calling convention, okay. Representation C, currently just tell us to try to pick whatever integer type that has the C compiler for the target platform would use for an enum, okay. With this RFC, the 2 new guarantees C and C++ compatible enum layout will be added. Okay, represent int on a non-C-like enum will now mean the enum must be represented as a C union of C structure that each start with a C-like enum with repr int. Okay, so int is int is a placeholder for one of these. So I think this is what we have right now. We have both of them. We have repr C and repr U16. The other field of the structure is the payload of the variant. Okay, so the layout will be my enum variant A, okie doke, and so each of them start with a tag which use int, which is the int specified here. So this is what I'm expecting to find actually. So in our case, we have a variant which should contain the tag and F32, and so we should find this. The problem that we okay, and so we have also. So maybe we have a problem because of these. Because we'll try something. If I remove it, it will not be that easy because it will not compile anymore. I want to see. Okay, I'm going to do it another way. I'm going to define a second enum, which I'm going to call op2. And what I'm interested in, I guess we can keep these. We can keep these. And we want to do some test on op2 size. So I'm going to assume that op2 is 12 because op was 12. So let's try this first. So I suspect the 12 is triggered by the move. So it tries to put one register on the second 4-byte word and one register on the third 4-byte word. So we have discriminant, padding, register ID first, padding, second register ID, padding. So we are wasting a lot of space, and the structure just, I don't need the release tag, it takes ages. So what I'm going to do is I'm going to check that this test is passing with 12, and I suspect that if I remove the move, then it goes down to 8. Okay. So let's try this. Okay, so that's my explanation was fine. So now the problem is why does it do this? So the C equivalent structure would be it looks like it is. I mean, if I read this. The other field of the struct are the payloads of the variant. Okay, so let's try something else. What if I'm doing repr C? Well, I have struct move. So if I'm reading this correctly, this should be the discriminant tag actually. So that's this is a U16 as here. Then we have reg1 as U8 and reg2 as U8. So my idea is this should be 4 bytes, but it looks like it's not 4 bytes but 12. So let's try it. So yes, move is 12 bytes. Okay. I'm surprised because I thought that this structure would have been packed. So everything on 4 bytes. So I guess what we need to check is how, and this was a link on the previous page. We have so this is a representation C. Okay. DST we don't care. DST nope. Enums. Tuple struct are like structs. The only different from struct that the field aren't named. Rep C is equivalent to one of the. So what are the structs? Where is the struct? Describe fieldless enum. Okay. Alternative representation. Data layout. Type layout section of the reference. Type layout, size and alignment, primitive data layout. Okay, representation. So here we go again. C. This representation of the type can be changed by applying the repr attribute to it. The following example shows struct with a C representation. If no representation is specified, the default one is altered. The alignment may be raised or lowered with the align impact. Okay. Okay, so the alignment is not my problem. My problem is more the packing. So back to 2. Okay, let's try to see. Alors, because of this dual purpose, it is possible to create tabs that are not useful for interfacing with the C programming language. Representation can be applied to struct, union, and enum. The exception is 0 variant enums. Okay. Represent C struct. The alignment of the struct is the alignment of the most aligned field in it. Okay. The size and offset of the field is determined by the following algorithm. Start with a current offset of 0 bytes. For each field in the declaration order of the struct, first determine the size and alignment of the field. So we start with, for our enum, we start with the variant tag, which is U16. If the current offset is not a multiple of the field alignment, then add padding bytes to the current offset until it is a multiple of the field alignment. Oh, that's fine. The offset for the field is what the current offset is now. Okay. Then increase the current offset by the size of the field. Yes, we've put 2 bytes, so we're counting 2. Finally, oh, and then we start again. For each field in the declaration order of the struct, first determine the size and alignment of the field. If the current offset is not a multiple of the field alignment, so I suspect that our problem is that the alignment for the register ID forces it on 4 bytes boundary. So we can check this. So I'm going to check alignment of register ID. And the question is align. Yes, align of register ID. And I'm assuming this is 4. Cargo test, what can I use? I can use off between underscores. So alignment of register ID is 1. Okay, so there is no reason why this register ID is put where it looks like it has been put. So we're going to try something. So I'm going to just do a memory dump of move. So let op equals up to move 1, 2. So they have to be register ID. So register ID B is 1, and register ID C is 2. And I want to see this type must be known at this point. It is known. Up to what? Up to move. Up to move. Ah, yeah, type. So I need to int this, I guess. Yeah, compiles, and so we'll do what? We'll do let so it's 12. So we know it's 12. So I'm going to do this bytes, and I'm going to use a transmute up, or even up actually. No need for this. This is unsafe, of course, no problem. And we're going to print this and have a look. At how it's encoded. So I'm expecting to see 0, 0, 0, run, 0, 0, 0, run, 0, 0, 0, 2. Once it compiles. And I need it to stop. Oh, I won't see anything. Try again. Okay, so I got the order wrong. I got several things wrong actually. So we have the discriminant on 4 position. Then we have the first register, second register. And why do we need all of this padding? This is super weird. So my hypothesis before was the padding was generated, the length of 12 was generated by the move and not by the other options, variants. So what if I'm doing this? So now T is not used anymore, which is a bit of a problem. Boom, boom, boom. Register, and let's remove our I don't know if I can do this. Nope. Okay, so now it tells me something. It is no longer 12. Okay. So is it 8? Nope. Is it 6? Nope. Is it 4? Yes. So now it puts everything inside the first 1, 0, 1, 2. Okay, so there is something I do not understand. There's something I do not understand in the way that these structures are stored. So I want to try something else. So I'm fine with, I'm okay with saying that, no, actually it doesn't work. So what I want is, I want discriminant over 2 bytes. So that's the beginning. What the hell? And then I want, for move, I would like this. So exactly what we have right now, actually. Reg 1, reg 2. And for the operation with constants, I would like disk. So that's the discriminant for the enum. And then I would like some padding. And my F32 constant here. The point of this is to keep F32 aligned. And I don't want the register to be stored into the second half of, I mean, into where the F32 goes, because we have, this is a move. This is like add const, for instance. There are a couple of other ones, but we also have a load. And so if we want to have the load on the same size, then we need it to work like that. And so yep. But the big mystery is, so with this, it does what I want for the move. If I'm adding the const, the add const, so the add const is F32. So now, okay, so we are at 8. Yes, okay. And so I want to see the move again. So the one thing is adding a new. I can see with what we were reading the specification before. I can see how adding a variant can alter the way another variant is stored, because it was essentially saying that each variant is encoded as the tag plus the rest of the structure. So it means this is complicated. So this was one, I mean, this is what I was afraid of, and I guess initially when I decided to put the constants separately. And what if I look at how the add const as a struct is stored? So same discriminant, register, oops, and a t, which is F32. So I'm assuming that this will go nicely to U88, add const, F32, this is dump of add const. So dump of add const is there, okay. And it looks like, yes, we have, I mean, the float is here, because that is part of the float. So by adding a variant, that is, I guess adding the variant somehow change the way the representation takes into account the padding for each field in declaration order in the struct. No, so that's not it. So this makes sense. I mean, we are keeping the F32 element aligned with a 4 byte boundary. So what if I'm doing this? I mean, we're going to have to play with pact, I guess, at some point, but I don't know how it works so yet. So let's not get ahead of ourselves. Okay, so that's the alignment pseudocode. Returns the amount of padding needed after offset to ensure that the following address will be aligned to alignment. Okay. Current offset equals 0 for field in field declaration order. Okay. And increase the current offset so that it's a multiple of the alignment of this field. Okay. Okay. So that's represent C unions, represent C fieldless, enum with fields. Okay. Okay. So tag the payload. This enum has the same representation as this struct. Okay, so tag and payload. Ah, this makes sense. Okay, now it makes sense. Okay. So the point is the fact that we add the move as a variant, or the add const as a variant, the myenum field union has to be aligned on F32 because one of the fields is F32, and so it has to be aligned. Okay. So this doesn't work for us. This doesn't work for us, but we'll keep reading because I suspect we are going to find out about pack, and if we can pack, then we kind of saved. I mean, it will mean that our F32 value will likely be in a not nice place. I mean, it will be between I think pack will be no padding, so no alignment. I think we need to check. And in that case, we will find our F32 in the middle of the register. I mean of the value, but it's okay. I don't mind. I mean, it's not as nice as I would like, but we'll make it work. So packed modifier. Alors, align and packed modifier can be used to respectively raise or lower the alignment of struct S and union S. Packed may also alter the padding between fields, although it will not alter the padding inside of any field. Inside of any field. The alignment specifies an integral parameter in the form repr align or repr packed. The alignment value must be a proper formula. For packed, it no value. Then the value is 1. For align, if the specified alignment is less than the elements of the type without the align modifier, then the alignment is unaffected. For packed, if the specified alignment is greater than the type alignment without the packed modifier, then it is unaffected. Okay, so packed is to pack and the line is to spacing up. The alignment of each field for the purpose of positioning field is the smaller of the specified alignment and the alignment of the field type. Okay. Inter-field padding is guaranteed to be the minimum required in order to satisfy each field possibly altered alignment. Also note that on its own, packed doesn't provide any guarantee about field ordering. Okay. An important consequence of this rule is that a type with rep packed 1 or rep packed will have no interfield padding. Let's try it. So what if I put packed here? Okay, it's not happy. Attribute should be applied to a struct or union, so it doesn't want it on the enum. That's not great. This is not good. Because what I wanted, I mean, yeah, I was considering this option. Without the padding. I mean, actually, okay, yeah, this is what I'm trying to get. So no pack on enum. Or true it is. Okay, I will not detail it, but this issue is very not about enum layout optimization, just like pack structure, not about layout optimization. Yes. I changed my mind. Since pack enum would have to carry some restriction as pack structs, field reference are unsafe. So are sadly much less useful than I was being given that matching by reference become unsafe as well. Huh. Because the alignment breaks stuff. Or the disalignment. That's a problem for me. That's a bit of a problem. Yeah. At least cause undefined behavior. In particular, most architectures strongly prefer value to be aligned. Yeah, no kidding. This may mean the align load are penalized x86 or even fault. Yes, on ARM. For simple case like directly loading or storing a packed field, the compiler may be able to paper alignment issue with shift and mask, which is what I wanted to do by hand. Or it's a reference to pack field, it's unlikely the compiler will be able to emit code to avoid an unaligned load. Yeah. Okay, so it looks like this is not a great option. We have another option actually. We have another option which is instead of, I mean, what we have is we have a stream of I mean what we initially have, what we initially had was before I start breaking stuff. We add a stream of 4 bytes operators and constant someplace else. And we had a relatively simple way to decode these instructions. What we could do is instead of but it will be messy. But I think that's what we need to do. Okay, so let me try to explain what I want to do. So we're going to use a union, and we're going to say that our stream, our program, will contain both instruction and the constants. All of them will be 32-bit. But the trick is, whenever we are working an operator that has an associated constant, then the operator knows that the following instruction is actually the constant. The problem is it will change, it will force us to change. I mean, we will not be able to represent this easily in Rust because we'll have this, we will need a union, as in C, not, I mean, a non-tagged enumeration, a non-tagged union. So sometimes it will be an op and sometimes it will be a constant, and Rust will let us do it, but it will not like it. Basically, it will be unsafe as hell. And so I think we should keep this high-level ops, and we will define another, I mean, we will define the program as different ops. So we will have low-level ops, and we will translate into the low-level ops and constant union. Yep, this is not. I'm afraid it's not going to be super nice. So we would keep this representation for. We will keep this representation. It will no longer need to be repr. It can be anything Rust wants to do with it. And we will translate it on the fly to a different representation, which will be easier to map to C. So let's try to write it. I think it's the first time I use the union in Rust. Op or const. And so it's the point where I actually need to look at the doc. repr, I definitely want this. And so we'll have another op. So I'm gonna call it op, ker op for kernel, and it no longer needs t because the constant has moved away, but we will need all of these. And I'm going to cut and paste everything and fix it. Let's go. So that's our second enum. So no T. Load doesn't have a T because it will be the next token in the stream. Same for these guys. Same for this one. Blah blah blah. So pour const, this one will be needing a type. And it will be either a carop nope, or it will be a blah, 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 constant. All right. One of the benefits of this is we can. I mean, if we translate the stream of instruction, we no longer need this. We no longer to have this repr C. So yeah, it's breaking everywhere, but that's fine. So we will start with the translation. So that guy is top level. To go over there. Up. Up, and so we will implement translate for implement for T LA datum we implement op of T, and there will be essentially one method translate. Oh, so my ops are 2 bytes wide. Yes, and some of them can have constant. Yes, repr does some crap with alignment and Rust doesn't allow you to pack in them. Exactly. Constants are also 2 bytes. No, my constants are, I mean, some constants, my constants are actually 4 bytes. And your solution is to have all ops to be 4 bytes with either 0 for ops with no const or the const value after the op. Yes and no. So the idea is so this care hop will be exactly what the op was until today. So it will be 4 bytes. Care hop will be 4 bytes. It will just have the registers, and so the registers are U8. So all of these should pack nicely on 32 bits. And so in my stream of operation, I will find either an operation or a constant, and this is why I need the union over there. So I'm going to assert later that this dude is actually 32 bits, and then it's just the context that will tell me if one 32-bit token in the stream of the program is an operation or a constant. I hope that's summary is understandable. Oh, and I will need a different program too to represent this program, and I will call it car program. Car means kernel. I mean, it's just to say that it's a low-level things. Are you man French? Because Doliprane sounds very French to me, actually. Are you somebody I know? Car op. So that's going to be a vector of. Yes, we know each other. Okay. Are you a colleague of mine? Clone, debug, partial, all of this is fine. Yes, okay, so I know who you are. I mean, I guess. Repc. I don't need. I don't think I need partial lake on these. I'm not too sure what is available on the union. I suspect that yes, no debug, because a debug cannot guess what it should implement, and no clone is not satisfied. It can be copied, so if it can be copied, then it can be cloned. Okay, that's good. So no debug for this. Okay, it's gonna be a bit of a pain not to. I mean, I can still implement debug by hand. I mean, it's the same. I can, yeah. I will just have to look at the instruction flow and decide, depending on the instruction before, if what I'm reading is a constant or, yeah, I can do the same. So if I really want it, then I can have it. And also I could also, even if it's a bit strange, I could also implement debug here, stating that yeah, if the value looks like it's a care hop, I display it, or else I display it as T. That would work in most cases. Okay. So the translate, I need the translate not on op, but I need the translate on the program, because I mean I could do it on the program too, but on the op too, but what I'm really after is on program. Translate self, and this will give me a care program T. Kidok, so let mut stream equals vec, and I'm going to wrap this into a care program of I want to call it ops. Let's call it ops. Cannot find the struct variant care program. What's wrong? Yeah. Okay. And then it's just a matter of translating. So I just need to loop over self.ops. And I need a big switch case. Something I should not forget is I remove the down from the high level one, so I still need to add it there. Why is it unhappy now? Because it expects vector. Oh yes, of course. So I guess this will be care. I need to wrap it into the union here. So the union is care op or const. Yes, and it's an op. It's tone. So that's not the right syntax. I need to write it like a struct. So it should be this. Okay. So big switch case match op. And here we go. And so this will be A and B. And it's going to translate. It's going to translate into care op. Yeah, that's absolutely right. Yeah, that's a small virtual machine. I think I'm actually using the term in the title of the stream. That goes through a VEC as memory. This part is more like very, very simple compiler actually, because I have one representation which I want to write code in, which is this one. And it turns out it's not the ideal representation for running. So I'm basically compiling it to a different form. So care op. I'm going to. I'm considering adding some helper traits. RAM is gonna be a mess. Let's forget about it and just write it. So it's op or const with op, and the op is a care op move A and B. And I need to push this into ops. So I need to keep the push here, because in some instances like this one, actually I will have to push two items in the ops. The const and the op, and then a const. So first I'm pushing load. So now it's going to be load A. And T, and I'm following with op const T. I think I called it T. Absolutely. Okay, it's not going to be boring at all. Can I cheat a bit? Yes. Ops point push. Oops. Ops point push op or const op care ops apps. So I think I can cut this, and that should be this one, that one. Oops. This one. So a couple more down there. Okay. So that's recip add sub mul min. Yep, that's absolutely fascinating. If positives and else, swap floor and 2 to the power 2 power of int. Okay, it's not happy. What did I miss? This. Then, so this one will be more like this one. Here we go. And this, nope. Ah, yes, need to be on the comma. And so these are const, so I'm gonna call them t. And I just need to fix these guys, so let's add const, subconst, mulconst, min, max, and FMA, and we're done with the translation. Good. I just hope we did not do that for nothing, and that we will be able to make everything else work again. So we have some errors here because dawn is gone. So this will happen whenever we are actually writing some of bytecode definition, like everywhere here. So I just need to remove dawn because now it will be added during translation. So it's nice because it's, I mean, I've been beaten once or twice for getting them. So having a mechanism that ensures they will be here all the time is actually not a bad thing. So that's for dawn. I think we are not done with compilation issue yet. So in the generic implementation, so the Rust implementation for the machine for the virtual machine, we have changed things. So now this is no longer a op, it will be a op or a const. And we need to fix it. Op or const, it's not imported, type is not imported. Yes. Okay, so this guy is happy now. So here we know that, I mean, this is unsafe, so we really need to make it right. But the assumption is when we get on the loop, we'll be on the beginning of an instruction. So an instruction is either 1 token or 2 token, and the first token is always the opcode. So we can do pc.op. And so now we are no longer dealing with ops, but with char op. So I'm going to transform all of these op into char op. Which I need to import, I guess. Okay, here we go. So now move isn't broken, but so the constants are no longer where they used to be. So now if we need to read a constant, we need to go and looking at this first. PC zero pointer, yes. So if I need a constant, okay. Where are you, Union? So if I need a constant, then it no longer comes from inside the element, but I need to do PC plus 1 dot t. So it's gonna be PC dot add 1, which I need to dereference. This is gonna be ugly. PC dot add 1 unreference dot t. Too many parentheses. Yeah, I don't need that one. PC add 1 is 0 pointer, so again the star is not where it should be. Try again. Yes. So it's a bit of a mouthful. How many do we have? What can I do to improve this? I could do a macro. Oh yes. Plus there is something else. If I'm reading a constant, then I also need to increment PC by 1. So to put PC on the next instruction. So we're going to do. We need to do it outside of. Need to do it like maybe something like that will do. So let t equals this. Here I'm using t, but here I'm also doing PC equals PC add 1, knowing that I think at the yes, here I'm doing the other addition, so that should work. Exactly. So one PC here for the instruction which have a constant, and one there for the instruction which do not have one. I mean, for all of them. I think that works. Show load if dest is A, if dest is B. Weirdly enough, we don't have load on C. Did I forget it? Oh no, it just doesn't need a if. Okay. So I think I'm gonna factorize these 3 things. So yep, I'm going to do that. So match DST. If DST is register A, then I'm doing this. If DST is B, I'm doing that. And if register is C, I'm doing this. So this one can go away. Syntax. Okay. moving on. So these guys are unaffected, and this one I must do more or less the same thing as here. And I can. Should I try to factorize this? It's a bit nicer if I do it like that, actually. Okay, let's because I could match all of them and then do inner. Yeah, let's try it. Let's see. Let's see. So I'm going to do undo. I'm going to do first. So they no longer have a constant. Yes. So first I'm going to do a match in match. So matching all of them, doing the constant extraction. Which is this bit, PC plus equal 1, and extract T. And then I need a match in the match, so I'm matching. It's no longer with me. I've lost it. I've lost it because it's now PC. I mean, it's yeah. So I'm going to do this. Let op equals pc.op. So that I can use it again. Match op. Okay. I no longer need to look into the constant. And here, that's just T. Okay, well, not okay, but it will be. What is this A? I'm not sure what this A comes from, but yeah, this looks fine. Missing, yes, so these other ops are unreachable. Okay, these one are not changed, and yes, we're getting there. So now here, this is no longer an op, it's op or const. I need to change the trait. So the trait is in src frame activation.rs. So it's the trait for the kernel's wrapper. So instead of running on op, it will run on op or const. And I have other implementation, I guess. What's what's wrong now? Expected slice found vec. Why did 161? Okay. So I no longer, I mean, that's, yes, so here now I need to translate. So krun, so this has to be, yes, this has to be op or consts and not ops. So I'm going to ops equals program. Ultimately, I will probably want to do this in a different place and not do it at every time the thing is called, but one thing at a time. Expected slice found car program, so that's car program. And I just need to pass car program dot ops. Okay, so we still have a couple of things that do not work, but we're getting there. So in test we have other definition of program. We no longer need the down bit. So nop is empty and max const is empty, is just max const. Activation in frame. 654. CRC frame activation. Am I in the right place? No. Yes, this one is an easy one. So, the trade bond T LA datum is not implemented. So we have a bunch of these. Yes, so it's just in the translation. I need some stars. Oh, what? So what's wrong? Ampersand T is not LA datum. Of course, it's not LA datum. So this is wrong. It should be op or const T and not ampersand T. So it's just a matter of yes. Okay. Well, maybe I can do it like that. Well, I will know when I've done all of them. Actually, I should do this. Let me do that. Vec op or const of T. Is it happy? Does it manage with this? Huh. Okay. No, it doesn't. It was just slow. Okay. So yeah. So I need the ampersand on T. So the rules of pattern matching in this kind of situation have been changed between. This still doesn't work. Okay. So they've been changed in between the first release version of Rust and like I think edition 2.18, and I'm still finding the new rules confusing. I mean, most of the time it does what you want, but it's always in this kind of halfway situation that things are, well, just confusing. It's not so bad, but here we go. Okay, so it's compiling. So we're going to test if the framework and the Rust generic fallback are still working. They're not even compiling, so we still have some work. SRC frame activations test. SRC frame activations test.rs test. Yes. Line 28. Okay, so this is a case where I'm actually I don't like this code. Yeah, I can just do that, I guess. Okay, it wasn't so bad. Except, yeah, this code is duplicated like 4 or 5 times already, and it's already in a macro. That's really bad. The translate. But these tests are meant to just test the kernel and not the framework around it. So we don't want to test. So we don't want to, I mean, we need to do translation by hand now. Activation generic, SRC generic, activations 119, and if we are running, it should be carop. And I need, yes, I need to change this guy, and it's not carop, it's actually carop of, I mean, this test is, it's an op or const, op or const. Do I need the F32? No, it will guess it hopefully correctly, but okay, so we have a couple of tests which are not working. These are my checking around stuff, and max const is not working. So let's do a bit of cleanup in activation test. So SRC frame activations tests alignment. It's not there. Where was it? It was in frame generic at top level. Yeah, this is where the structs and union and etc. are defined. So what do I want to check? I want to check that. So I will remove these. So I want to check that op or const F32 is 4. And I'm going to just let the rest go, because this was really about investigating the alignment stuff. Okay, so max const doesn't work anymore. Yes, this is very much not 0. So I'm going to look at this one because this one is an actual unit test and this is a property test. So this is why we get 4 results. I mean, that's something we investigate last time. But for now, we're just going to look into this one. Okay, so what is happening? The good thing with the Rust fallback is it's in Rust, so we can debug pretty easily, except yes, op is still debug. Yeah. So we should see a max and we should see down. And we see max const and we see down. It's actually not too bad. So in the min max here, so we are going there and let's have a look at T. And the T is 0. And I think this is not what we want. I think 0 should be, I mean, T should be the big value. So let's go back to our translator. And the translator is here. And we are going to debug each op. Let's see where we are. Oh, I know, it's gonna be stupid. So we are going to see 0 here. Yes, max const 0. So I think max const, where is it defined? It's a test. So it's in activation tests and it's there. And instead of using the constant that I was given, I just put a 0 because it was a 0 before. So I did the translation naively. It was 0 because it was constant number 0, and now it's the actual constant. And it's working. Okay, so we're going to try to fix the assembly, the ARM8 assembly, because it's necessarily broken now. I'm going to remove the debug I've put everywhere. So I have some in activations, src lib. Okay, this one I keep. Src frame activation. Yeah, GG, well, but we're not done because now we need to fix the assembly. And if it goes like the other day, well, dbg and dbg. Okay. So let's see if my Raspberry Pi is still working. Okay, and the code is not compiling, which is expected. I mean, more or less. So here it's because the code that create the extern function, the C function, which is actually an assembly function that we are calling, need to be fixed for the new op or const. I fixed it the first time for the removing the constant, but we also need to do that. Okay, 215. Yes, so this is a op or const of ty. And op or const is not found. Yes, yes, op or const. I probably no longer need this one, and I should use create in this context because we are in a macro, and even if the macro is not supposed to be used outside, it's more consistent at least. Okay, looks good. I mean, it's compiling, but there is no way it can work because we need to fix everything about our assembly code. So let's have a look. ARM64, ARM64, SIMD, and it's ARM64 SIMD activation template. Okay, so now first of all, this changes. So this is no longer op, it's now op or const, and the consts are gone. So x1 is now the x's, and x, the length of x is in x2. Okay, so first let's try and fix the loading. So whatever works with x1 and x2. So loading of data. So the address where x2, now there are x1. We are moving x1. This is in a loop. Then we are storing to x1. And we are managing the counter in x2 and no longer in x3. Okay, so that's it for the data. Now the operators, the operations. So it is still valid to load and to move by 4. It's just that now instead of and we will probably do it better at some point, but so this is the value that we are putting in the in L1, I mean in V24. So we need to now to extract this value. So here we are loading from memory, and now we are going to we can still load it to memory. Actually, we will start with this. So first implementation, we are going to load it from x5, and we are going to move x5 by 4, and that's it. We no longer this stuff. So I don't like it very much. I don't like it very much because we are still but I mean, it's okay, it's working. I mean, I think it would be better if we could load, instead of loading one value at the beginning of the load here, I want to load two. It's a bit tricky. I want to load two, and so if it's an op, then if it's an op without a const, then well, that's fine. But if it has a const, it's already in a register, and here instead of loading from memory, I can pick the value in a register, which I think there are instructions on ARM to move a value from a general purpose register to SIMD. I think because there are architecture where you can do that, but I think if I remember correctly, we can do this on ARM. How to load vector register from integer register in ARM64? Yes, that's what I want. Yes, that's it. Move. This is a register vector, and this is a general purpose register. So we can actually do it. Except, yes. No, I thought it was. I mean, I had at one instant I thought it was, and my test is working. So we did it right, I guess. We did it right the first time, or maybe not. Okay, no, but this one I expected to fail because we haven't implemented the other functions. Okay, so the problem with loading because here if I want to load, I could load a pair of registers. I could load it as a 64-bit register, but I think in that case I need it to be aligned, and the problem is, I mean, aligned to 64-bit, we are no longer aligned because we are aligned on only 32-bit address. I don't know about that actually. What does LDR accept? Alignment and NDNS. So that is that LDR? Yes, but it's not LDR vector. It's LDR to a general purpose register. Does arg64? Yeah, I mean it's almost gone on line access. At best, still takes at least one cycle longer. So there is one other way, which would be to use LDP with two 32-bit registers. I'm gonna commit this before doing anything more. Looks good. Doesn't look too good, but at least it's correct. Okay. Okay. Commit move constants in stream. So if I want to do this, if I want to load my two registers here, I could use, for instance, I could use, I think so LDP. Well, I need to open this absolutely terrible PDF once again. If I can find it. Where is it? Where is my Bible? My Bible is here. So it's just a big PDF, like big, like thousands of pages. Why did you dismiss the LDP solution? I haven't dismissed it yet. I'm trying to. This is why I'm opening the damn PDF. It's because I want to see exactly what are the constraints on LDP and on LDR. So LDP is load pair. So I think I should be able to load W. I mean, the pair needs to be contiguous, but so we need to work again. I mean, to move again some stuff around. But it's probably the best way to go. Oh yeah, it opened on the other screen. Where did it go? I'm not sure where it went actually. Where are you, big PDF? Okay. Something very weird is happening. So it just disappeared on me now. It's there. I can see it on the other screen. Will you show up? No, it doesn't want to show up. Okay, so let's kill you and give it another shot. Yeah, I mean, this information is in the cloud, absolutely. It's just that I mean, on the ARM website is yeah, okay. The thing is, I mean, it's not. Oh yeah, wide open. Still a good question. I mean, it's a bit frustrating that there is, yes. I mean, I don't like the ARM website, to be honest. I think it has too much Chrome all over the place, and the information that you are looking for is spread over dozens of pages, and so yeah, I don't like it. So I like this PDF because even if it's not perfect, at least I know where to look and kind of like that all information about one instruction is in one single place. So what I want to do is so one option is to use LDP, load two 32-bit registers or two 64-bit double word from memory and write them to two registers. So that's not too bad. I'm just wondering if we need them to be contiguous. I think we need that, but I mean it's okay. It supports pre-index, which yeah, that's all right. Okay, let's try it. Yeah, so does it have to be contiguous? 32-bit name of the first GP to be transferred and code in RT. No, it doesn't have to be contiguous. Okay, even better. So we can keep and the syntax. The syntax will be what? Oops, I moved away. So the syntax will be LDP register address. Okay. So we are going to load in W6 and the other constant. I will put it in. Oops, I forgot this one before. This one should be X2. because I will put the other in W3. So W6 is fetch instruction, W3 is next or constant. And now here I can use insert v24.s 0 w what w3, and so we're no longer eating the memory here. One stuff we need to do if we want to do this is it's a bit of a hack, but when we are reading, when we are at the end of the stream, we are going to read down as the first, the thing that lands in W6. And if I don't do anything, in W3, I will read over. I forgot to change the instruction name in the inner loop. Yes. Thank you. Oh, and there is something else. So first thing, so when I will be at the end of the stream, I will put W6 in down, but W3 will be an overrun in the buffer. So what I need to do is I need to add one more element in the care op vector, not to go over. So let's do this before we forget about it. And so in the translate, it's a bit hackish to do it in translate because it's really something that depends on the actual architecture, but it's really harmless, and it's going to help us in, I mean, I guess in over all architectures. To help with per load, or I could give it a constant of 0. Yeah, it would be it would work too. Whatever. I mean, there just need to be something. I could even play. I mean, as it's a vector. I mean, it would be super messy. Okay, so now this is done, and I still need to increase my PC here so that it points to the next instruction and not the constant that I've been using. And I'm not sure about this. I don't know if it's valid to read 8 bytes and increase the the offset by 4. I'm not sure it's allowed. We'll see. Anyway, here I need to add to x5. I need x5 plus 4. Seems happy with this actually. Okay, so we still have the same 5 tests failing. So it's super nice because I think on most small Cortex A53 or A55, this can actually be done in one cycle. I mean, one cycle to start the instruction, then a couple of them to actually fetch data. We could also try to be smart here and preload W6 so that, because this instruction will wait, the end here will have to wait for the load to be finished. But I think loading 1 or 2 word will take the same time in this specific case. So I guess what we just did is more or less free. Ideally, yes, we would want to move this next instruction load just right after the decoding. So, but it's, I mean, it starts to be a bit complicated for this first implementation. So yeah, there is a memory latch. I mean, most of the time it should be like it should be in the first cache or in the L1 cache. Or that's going to be like 3 or 5 cycles, something like that. So not too bad. And here we don't have any memory access anymore, so that's a good point. Okay. I'm wondering if I'm going to have a look at the to-do list. So rework the protocol so constants are in the flow of instruction. We just did that. Tac. Should we have a look at the jump table? I think it's. I think the jump table will take us like a full session. So I'm probably going to stop here for tonight. How long has it been? Oh, it's already a 2 hour session. So it's yeah, it's already a good one. Okay, so well, thank you for watching, and I think next session will be next Monday, same hour, and we'll probably look at the jump table generation. So the idea in the jump table, I'm gonna do a bit of teasing. The idea of the jump table is here, if we do it by hand, we will do lots of comparisons and to try to jump at the right place. And there are nice tricks using direct manipulation of the instruction pointer to avoid this. So we'll see that next time. I've already done it once, so it should go well, hopefully. Thank you. I'm happy you liked it. Oh la la. And see you guys soon. Where is OBS? OBS, yeah. Bye, guys.